Hi guys, and welcome to Module 4. Module 4 has to do with fractions. In this lesson, we are going to use the greatest common factor and least common multiple when we add, subtract, and multiply fractions. In this slide, we are asked to multiply 1/3 times 3/5. Product is a times word. It means to multiply, and they're asking for this answer in simplest form. So that means that we can simplify at the beginning or we can simplify at the end, but we must simplify. I have told you guys that it's easiest to simplify from the beginning. So let's go ahead and take a look at 1/3 times 3/5. When you simplify, you can take the greatest common factor between a numerator and a denominator in order to simplify the fraction. So in this case, I am seeing that the 3 denominator in 1/3 and the 3 numerator in 3/5 have 3 as their greatest common factor. So what I can do is I can go ahead and simplify. I'm going to write the fraction, I'm going to go ahead and write the fraction here, 1/3 times 3/5, and that way you guys can see how I'm going to simplify this. The greatest common factor between 1/3 and 3/5, denominator with a numerator, 3 goes into 3 one time, 3 goes into itself one time. And now the rule to multiplying fractions is you just multiply the numerators straight across, so 1 times 1 is 1, and multiply your denominator straight across, 1 times 5 is 5, and so the answer here is 1/5, simplest form. Okay, let's go ahead and try another. We have 6/7 times 2/3, and I want to see if there is a denominator and a numerator that have a GCF, or greatest common factor. I'm going to rewrite the 6/7 times 2/3. And I see that this denominator of 3 with this numerator of 6 have 3 in common. 3 goes into itself one time, 3 goes into 6 two times. I can't do anything with the 2 and the 7, so I'm going to go ahead and multiply straight across. 2 times 2 equals 4, and 7 times 1 equals 7. Simplest form, the answer is 4/7. Now, what does this look like in a word problem? Let's take a look at this picture. We have 2/3 of a bag of flour. We use 3/4 of the flour to make empanada dough. How much of the entire bag do you use to make the dough? Well, we need to first stop and process and think about important information. The contents of the bag of flour that we have is 2/3. We don't have a full bag. We only have 2/3 of a bag to begin with. But we don't use that entire thing to make the dough. We only use 3/4 of it. So in this problem, to answer the question, how much of the entire bag do we use to make the dough, we need to find what 3/4 of 2/3 is. Now, of is one of those multiply or divide words based on what it is that they're asking. In this case, we didn't use the entire 2/3. We used 3/4 of it. So we want to know how much that amount of the 2/3 is. So we're going to go ahead and multiply 3/4 of 2/3. And here I see that I can do some heavy simplifying because I can do it on both sides. So I'm going to go ahead and simplify the 3's. They go into itself one time. I'm going to go ahead and simplify the 2 and the 4. 2 goes into itself one time, and 2 goes into 4 two times. And I'm going to multiply straight across. 1 times 1 is 1, and 2 times 1 is 2. My answer is I used a half of the entire bag to make the dough. Now in class, we've spoken a lot about the power of estimating and how we don't use it as often as we should. When we estimate, and it serves as a really good guide to let us know whether our actual answer is on the right track or if we are way off and we need to rethink about what we're doing. In this slide, we have an example of a class that has 18 students. Total number of students is 18. That's important information. The teacher asks how many students in the class have pets, and she finds that 5/9 of the students have pets. Now, how many students have pets? If I were completely lost on how I would find the actual answer, I could begin by estimating, and then once I have that estimate and I get my actual, I can see whether I'm on the right track. Well, we're going to want to see what 5/9 of 18 is. So we're going to want to multiply 5/9 times 18 to find the actual answer. But since I'm estimating, I'm going to think about 5/9 and I'm going to think about benchmarks. Now my denominator is 9, so that's into how many parts it's been divided. My numerator is 5, which is really close to half because half of 9 is 4.5. So 5/9 is not closer to 0. That would be like 1/9. 5/9 is not closer to a whole. That would be like 8/9. 5/9 is really close to the half because half of 9 is 4.5. So when I'm estimating, I'm going to go ahead and do 1/2 of 18 students. And the 18 is a whole number, but we know that if we set that up as a fraction, we just set it above 1 and it doesn't change its value. Now I can look into simplifying. I can see that 2 goes into itself 1 time and it goes into 18 9 times. And so when I multiply straight across, 1 times 9 is 9 and 1 times 9 is 9 and 1 times 1 is 1, leaving me with 9 over 1, and anything over 1 means that's the whole number. So my estimate here is 9 students out of her 18 students have pets. When I do my actual answer, if it's close to 9, then I know that I must be right or definitely on the right track. If it's way off, then I've done something wrong. So let's go ahead and calculate 5/9, because now I'm doing the actual, exactly 5/9 of the students have pets, of 18 students. I'm going to go ahead and simplify. 9 goes into itself 1 time, goes into 18 2 times. And 5 times 2 is 10. 1 times 1 is 1. Anything over 1 means that is the whole number. And the actual answer is 10 students have pets. Close to my estimate? Absolutely, so I know that I'm right. Now let's review adding and subtracting fractions with different denominators. The highlighted information gives us really good information on what happens when we have to add or subtract two fractions that don't have the same denominator. If they don't, we're going to find the least common multiple of the denominators, and then we're going to rewrite the fractions. And we learned this back in a previous module, but let's go ahead and just review it. So if I have 8/15, and I've told you guys if you're adding or subtracting fractions with different denominators, set them up vertically, and that way it's easier to set it up. Plus 1/6, and we're going to go ahead and think about the least common multiple between 15 and 6. And what I like to do is I always like to start with the higher number. So I'm going to start with 15 and I'm going to go, okay, well 15 is not going to work because nothing times 6 is 15. So let me go to the next multiple of 15, which is 30. 30 will work, and so that's going to be my new denominator. And now I have to see 6 times what number will get me to 30. Well, that's times 5. That's the magic number. What I do to the denominator, I must do to the numerator. 1 times 5 is 5. So an equivalent fraction to 1/6 is 5/30. And now we want to do the same thing to the 8/15. So 15 times what number will get me 30? Well, that's 2. What I do to the denominator, I must do to the numerator. 8 times 2 is 16. Now that I have common denominators, all I have to do, that denominator always stays the same, and I just have to add 16 plus 5, which is 21 over 30. And so my answer here is 21/30. Some of you might be thinking, wait a minute, Mrs. Figueroa, you can simplify this because they are both divisible by 3. And I'm going to say great job there because you're absolutely right. 21 divided by 3 is 7. 30 divided by 3 is 10. And so the simplified answer here is 7/10. So let's practice some more real-world situations when we have to multiply fractions. In this example, Kate wants to buy a new bicycle from a sporting goods store. The bicycle she wants normally sells for $450. The store has a sale where all bicycles cost 3/5 of the regular price. Well, that's important information. The fact that it was originally $450 and now there is a sale where they cost 3/5 of the regular price. What is the sale price of the bicycle? So what we really want to find is what is 3/5 of the original price, which is $450. So we set that over 1. We can go ahead and simplify. 5 goes into itself 1 time. I know that it goes into 45 9 times, and I can't forget that 0, so that's 90. My answer here, I can't simplify anymore, is going to be multiply the numerator straight across. 3 times 90 is 270. 1 times 1 is 1, and so we understand that anything over 1, that is the answer, and that's the whole number, 270. I want to kind of take a moment to talk about what we discussed in class, the difference between of and off. Because if they're just asking us for 3/5 of the regular price, then that just means we multiply it. This is what she's going to pay. That's it. But if it had said off the regular price, then that would mean that that's the discount. So that means that we would have to subtract that amount from the original price, and that will tell us how much she pays for the bike. But in this case, she's just simply paying 3/5 of, not off. Now let's move on to dividing fractions. When you divide a number by a fraction, you really end up multiplying that number by the reciprocal of the fraction. So if, for example, we started off with a fraction like 1/5 divided by 3/4, we would keep that first fraction the same. So 1/5 stays the same. The division sign changes to multiplication, and now we do the reciprocal of the second fraction, so we technically flip or invert that second fraction. So if we have to divide 1/5 divided by 3/4, the rule says we're really taking 1/5 and multiplying it by 4/3. Okay, so let's go ahead and practice dividing 5/9 divided by 2/3. I am going to keep that first fraction the same, 5/9. The rule says change that division sign to multiplication, and I'm going to do the reciprocal of 2/3, which means I'm going to flip that second fraction, and it now becomes 3/2. I'm going to use everything that I know as far as multiplying fractions. I know that I can simplify the 3 and the 9. 3 goes into itself 1 time, goes into 9 3 times. There's nothing I can do with the 5 and the 2, so I'm going to multiply straight across. 5 times 1 is 5, and 3 times 2 is 6. My answer is 5/6. Now let's take a look at a real-world situation where we have to divide fractions. In this example, we have 3/4 cup of salsa for making burritos. Each burrito requires 1/8 cup of salsa, and the question asks, how many burritos can I make? I remember the most difficulty that we had in class when we were dividing fractions was thinking about which fraction came first. And we discussed how the fraction that goes first is the total, the entire amount that we're dividing. So in this case, we have 3/4 cup of salsa. And we're going to divide that by, well, every burrito requires 1/8 cup. So we're going to divide by 1/8 because we're really wanting to know how many 1/8 go into 3/4. That's really what this problem is asking. So when we have 3/4 divided by 1/8, we know that we're going to change that division sign to multiplication, and we're going to do the reciprocal of the second fraction. So 1/8 becomes 8 over 1. We're going to go ahead and simplify. 4 goes into itself one time, goes into 8 twice, and so the answer is 6 over 1 or 6. So we can make a total of 6 burritos that require 1/8 cup of salsa if we had 3/4 cup of salsa. Here's another real-world example that we can practice for division of fractions. We have 5 people sharing half a pound of cheese equally. We have those keywords of sharing and equally, so we know that we're going to divide. How much cheese does each person receive? Well, again, we have to think about what number is going to be my dividend, my first number. He's the one, my total that I am dividing. Well, we're not dividing people. We are dividing half pound of cheese. So we're going to go ahead and set up half divided by 5 people. And we know that this is going to turn into keeping the first fraction the same. The division sign turns to multiplication. And then we're going to do the reciprocal of the second fraction. So this is going to be 1/5. And so everybody is going to receive 1/10 pound of cheese. Again, let's try another example just to practice who our dividend and our divisor is going to be. Allison has half a cup of yogurt for making fruit parfaits. Each parfait requires 1/8 cup of yogurt. How many parfaits can she make? So the question is asking us if we start off with half a cup of yogurt, and that's my dividend because that's how much total yogurt I have, and I'm going to divide that by 1/8 a cup because that's how much each yogurt parfait requires. Then I'm going to go ahead and follow through with keeping that first fraction the same, changing that division sign to multiplication, the 1/8, do the reciprocal of that, so that's 8 over 1. We can simplify. 2 goes into itself one time, goes into 8 4 times, so we can make 4 parfaits with half a cup when each one requires 1/8 cup of yogurt. I also introduced you to a little bit of simple algebra. I asked you if I asked you to divide B divided by C, and we talked about how that would be impossible because in our world we don't divide letters. But when letters represent a number, those are variables, and so B does represent something, and it does tell us what they represent. So now we can easily do this. B is equal to 5/8, so we're going to go ahead and replace or plug in or substitute 5/8 for B. That is divided by C, and C is 2, and I can see that up here. Now, the rule says we're going to keep that first fraction the same. We're going to turn that division to a multiplication, and we'll do the reciprocal of 2 over 1, which is 1/2. Nothing here that I can simplify because you cannot simplify a denominator with a denominator. So I couldn't look at the 8 and the 2, which is a common mistake. So we're going to go ahead, since we can't simplify anymore, and we're going to multiply straight across. 5 times 1 is 5, and 8 times 2 is 16. My answer is 5/16 for the first one. Now for the second one, again, we're going to take C represents 2, so we're going to plug that in. Divided by A, in this case, A is equivalent to 1/4. And so I'm going to go ahead and the rule tells me the 2 stays the same. I'm going to set him over 1 because I know that I'm dealing with fractions. I'm going to turn that division sign to multiplication, do the reciprocal of 1/4, which is 4 over 1. Again, I cannot simplify a numerator with a numerator, so I'm going to go ahead and multiply straight across, 8 over 1 or 8. Now what happens when we have a mixed number and we have to divide that by a fraction? Not much changes. We know exactly what to do with a mixed number. We need to turn him into just a numerator and a denominator, and we certainly know how to do that. Welcome back to the circle dance, where we take that denominator, we multiply it by the whole number, that's 8, and then we add that to the numerator, which is 9 over 2 divided by 3/8. And so the hardest part about this was just changing that mixed number to an improper fraction. And we certainly know how to do that. And now we go ahead and we finish this off. We're going to go ahead and keep that first fraction the same, 9/2. We are going to change that division sign to multiplication, reciprocal of 3/8, which is 8/3. A lot of nice simplifying going on here. 2 goes into itself 1 time, goes into 8 4 times. 3 goes into itself 1 time, goes into 9 3 times. And so my answer is 12/1, or simply 12. Okay, so what happens when we have to divide mixed numbers and they are both mixed numbers? That's very simple. We will just do the circle dance on both of them and we can find the improper fraction for both. So we take the denominator, multiply it by the whole number. 6 times 3 is 18 plus 5 is going to be 23/6. We're going to divide that by, again, we do the circle dance, denominator times whole number. 3 times 1 is 3 plus 2 is 5. Oops. And so that's going to be 5/3. We're going to go ahead and rewrite that. That's 23. That first fraction stays the same over 6. Division turns to multiplication. We do the reciprocal of 5/3, which is 3/5. And let's see. We definitely can simplify. 3 goes into itself 1 time, goes into 6 twice. And that's pretty much it. We're left with 23/10. Now, if we were putting this in ScoopPad, we would leave it 23/10 because that's how the system likes it. If it asked you to simplify it, then you would go ahead and convert this to 2 3/10. But if it does not, then go ahead and leave it as an improper fraction, 23/10. Okay, let's try dividing fractions with real world situations. So in this example, we're making sushi rolls. This gentleman has 2½ cups of rice and he will use 1/4 cup of rice for each sushi roll. Asking us how many sushi rolls can he make. Again, we want to think about what number we are dividing. That's the dividend, that's the number that goes first. He has a total of 2½ cups of rice. And if he's using 1/4 cup of rice for each sushi roll, we're going to divide that by 1/4. We really want to know how many fourths we need to complete the 2½ cups of rice. Well, let's go ahead and do the circle dance since we have this mixed number. 2 times 2 is 4 plus 1 is 5. So this is 5/2. We're going to turn that division to multiplication and we're going to do the reciprocal of the second fraction. We're going to go ahead and simplify. 2 goes into itself 1 time, goes into 4 twice. 5 times 2 is 10, 1 times 1 is 1, and so this gentleman can make 10 sushi rolls with 2½ cups of rice that require 1/4 cup for each sushi roll. Let's look at another real-world problem involving dividing mixed numbers. This one says 1 serving of Harold's favorite cereal contains 1 2/5 ounces. How many servings are in a 17½ ounce box? So what we really want to know is how many 1 2/5 ounces are in a 17½ ounce box. So because that's what it's asking us, the 17½ is the dividend, that's the total. We're going to divide that by 1 2/5, and this is a mixed number divided by a mixed number. So let's go ahead and turn those into improper fractions. 17 times 2 is 34 plus 1 is 35. That becomes 35/2 divided by 5 times 1 is 5 plus 2 is 7/5. The rule says keep that first fraction the same, 35/2. Change that division sign to multiplication and do the reciprocal of 7/5, which is 5/7. In here, we can simplify the 7 and the 35. 7 goes into itself 1 time, goes into 35 5 times. My answer here would be 5 times 5. I'm going to carry it over here. 5 times 5 is 25, and 2 times 1 is 2. And so my answer here would be 25/2. Again, if this were just asking you like on a ScoopPad question, then leave it as an improper fraction. If it did say simplify it, then you would go ahead and say, well, 2 goes into 25 12 times with 1 left over, and my denominator is 2. I'm going to suggest that you keep them as an improper fraction for now, and if it asks you to simplify, then you can go ahead and turn it into a mixed number. I wanted to explore this question with you guys because this is very similar to that ScootPad question that you guys saw dividing fractions with area. This one says the area of a rectangular sandbox is 56 2/3 square feet. The length of the sandbox is 8.5 feet. What is the width? Well, our background knowledge, we should already know that the area of a rectangle equals base times height. With that background knowledge, if they already give us the area, then we're no longer going to multiply. We're going to do the inverse of multiplication, which is division. Because in this case, they already they provide us with the area and they provide us with the length, and our job is to find the width. So instead of area equals base times height, now we have area, which is 56 2/3, divided by the length, which is 8.5 feet, and that's going to then give us the width. So we're going to go off to the side. We're going to do 56 times 3 because we have to turn that to an improper fraction. That is 168 plus 2 is 170 over 3. We're going to go ahead and turn this into an improper fraction as well. So 2 times 8 is 16 plus 1 is 17 over 2. We're going to keep that first fraction the same, 170 over 3, change that division to multiplication, and do the inverse of the second fraction, 2 over 17. We're going to use our simplifying skills, and we're going to go ahead and simplify. 17 goes into itself one time. It goes into itself one time, but we can't forget about that 0. And so 10 times 2 equals 20. 3 times 1 equals 3. And so my answer here would be 20 over 3. If we wanted to turn that into a mixed number, I'm going to go over to this side. That means that 3 goes into 20 6 times with 2/3 left over. So if we wanted to find the area and we had 8.5 feet as the length and 6 2/3 feet as the width, then we would be able to multiply 8.5 length times 6 2/3 width, and that would give us the area, 56 2/3. In this case, we had to do the inverse. We had to do the division of the area, 56 2/3, because that total was already provided. And if we divide that by the length, that will then give us what the width of that sandbox is. Now, we talk a lot about being able to explain and justify our thinking, and so this is a really good question that allows us to do that. In this question, we're told that 1 serving of tortilla soup is 1 2/3 cups. They tell us that a chef makes 50 cups of soup, and then they ask us if there is enough to serve 35 people. So in this scenario, we would put ourselves in like a restaurant management business, or we are the owners of this restaurant, and we want to make sure that we can cater to our customers. Now, the question is telling me the cook makes 50 cups of soup. We know that each serving is 1 2/3 cups, and we want to know if we can serve 35 people with this serving size and this amount of soup. So the total amount that was made by the restaurant cook was 50 cups of soup. So we're going to take 50 over 1, and we're going to divide that by each serving is 1 2/3 cups. We're going to turn this into an improper fraction in order to divide it. So we're going to go 1 times 3 is 3 plus 2 is 5. So we're going to leave this is 5/3. We're going to leave that first fraction the same, 50 over 1. We're going to turn that division to multiplication, and we're going to do the reciprocal of 5/3, which is 3 over 5. We're going to go ahead and simplify. We know that 5 goes into itself one time, goes into 50 10 times, and 10 times 3 is 30 over 1, or 30. That means we have enough soup to serve 30 people. And so in order to answer this question, we would be able to justify it by saying that unfortunately, the 50 cups of soup at 1 2/3 cups of servings for each one would only serve enough for 30 people, not 35. Another real-world problem with fractions and mixed numbers, we have a rope that is 25.5 feet long. This gentleman wants to cut it into 6 pieces that are equal in length. These are the key words that let us know that we're dividing. Cut, equal. We're going to go ahead, and we should know by now that our dividend is the total that we're starting with. So it is not the 6. That's how many pieces that we're going to cut it into. So we're going to take our total of 25.5. That's how much total rope we have. That we can divide by 6 over 1, and that will tell us how long each piece will be. We're going to turn this mixed number into an improper fraction. 2 times 25 is 50, plus 1 is 51 over 2, divided by 6 over 1. Rule tells us keep that first fraction the same, change that division to multiplication, and do the reciprocal of 6 over 1, which is 1/6. I believe that 3 will go into both 6 and 51. And let me go off to the side and see if that is the case. And it is. 3 will go into 5 one time. The divisibility rule of 3 says that if you add the numbers together, so like 5 plus 1 is 6, and if it's a multiple of 3, then you know that it's divisible by 3. So that's just a little hint for divisibility rules of 3. So knowing that, I know that 3 will go into 6 2 times, and it will go into 51 17 times. And so now I can just multiply straight across. 17 over times 1 is 17, and 2 times 2 is 4. And we can go ahead and either leave this as an improper fraction, or 4 goes into 17 4 whole times with 1/4 left over. We also talked about the order of operations and how we can solve multi-step problems with fractions and mixed numbers using our order of operations. We did some fun hopscotch with the order of operations outside of our room. And I just want to remind you that the order of operations is parentheses, exponents, multiply, divide, add, subtract. We clarified some misconceptions about order of operations. We talked about how parentheses is always the top one. It is the one that you do absolutely first at all times. He is the king. We talked about exponents being the second one that we do, and that is the queen. We talked about multiply and divide, and we talked about how they're equal. That's prince and princess. They are equal. We sometimes want to think that multiply comes before divide, and that's not the case. It's multiply, divide, whatever comes first from left to right. And then lastly, the same thing applies with add and subtract. You don't necessarily add first. You can add or subtract based on whatever comes first from left to right. So if we have a problem like 4 squared divided by 2 plus 3 times 9 minus 5. Order of operations, this is a really long expression, but we can do this one step at a time, and we will get to the answer with no problem. We'll start with parentheses. So we're going to go ahead and rewrite everything else. 4 squared divided by 2 plus 3. And we're going to take care of what's in the parentheses first. So 9 minus 5 is 4. Okay, took care of the parentheses. Great. Now let's go to exponents. We do have an exponent here. We have 4 squared. And 4 squared means that I'm taking this base number 4 and I'm multiplying it this many times. So I'm taking 4 and I'm multiplying it by itself twice. So 4 times 4 is 16. Rewrite everything else. Divided by 2 plus 3 times 4. Took care of the exponents, great. Now we multiply, divide, whatever comes first. In this case, the division comes first. We're going to take care of 16 divided by 2, which is 8, plus 3 times 4. We don't go to the add or subtract yet because we still have a multiplication. When you see these parentheses here and they are between numbers, that means that you multiply. So 3 times 4 is 12, and now we bring everything else down. 8 plus 12, and 8 plus 12 is 20, and our answer here is 20. This concludes our Module 4 on fractions. If you have any questions, please feel free to ask.